Everyone, welcome again to today's tutorial, and today under physics we'll be discussing Bernoulli's equation. Bernoulli's equation deals with conversion of energy, and the law of conversion of energy says energy can neither be created nor destroyed but can be transferred from one point to another with the average particle remaining constant. That is to say, at each point in this pipe, if I'm having 100 joules of energy, also at this point I'm to have 100 joules. That is the law of conversion of energy. At every point I'm having same amount of energy. So it is based on the law of conversion of energy. Now, why Bernoulli's equation? Let's imagine I pour a fluid inside this pipe. Now, the speed at which, the average speed at which the fluid flow, like as the speed increases, the pressure of this fluid or of the container will decrease. So the increase in the speed of the fluid will lead to the decrease in pressure. Now, we want to get the Bernoulli's equation. In Bernoulli's equation, we deal with pressure plus the average kinetic energy or the kinetic energy and the gravitational potential energy. So this will be a shorter way to derive Bernoulli's equation. Now, we know that potential energy is half mv squared plus, and gravitational potential energy is mass times acceleration due to gravity times height. But in dealing with fluid, physicists don't use mass, they choose to use density in dealing with fluid. That is, I change my density, my mass here to density, then I'm having pressure plus half density, which is rho v squared, plus mass times, we are not using mass, we are using density g h. Now, this is Bernoulli's equation. Based on the law of conversion of energy, I told us at this point the energy will be same thing. That is, I'm having P1 or is equals to P2. Then here we'll be having P1 plus half rho v squared plus dh will be equals to P2 plus half rho v squared plus density GA. So while writing this, I want to suggest that since we are dealing with law of conversion of energy, the energy remains constant at every point. That is, this here, the half density v squared, the amount that we have will be the same amount we have here. But when it comes to the pressure, when this pressure is small, then this pressure will be large, and vice versa. And also, when the gravitational potential energy is large, at this point, this will be small. So this is what I want us to get based on Bernoulli's equation. Thanks for watching today's tutorial, and in our subsequent class I will solve questions on this.